Hello, honors pre-calculus students. Today's learning target is to maximize the volume of a rectangular prism. So the setup of this problem is we had a piece of paper that is 14 inches by 24 inches, and you're going to cut out a little square that I highlighted in yellow from each corner, and I called that X. Then, if you were to fold after you cut it out, the paper along these dotted lines here, you will then make a rectangular prism, which I drew on the right-hand side. So we know that the volume of a box is length times width times height. So when you cut or you fold along the dotted lines after cutting out each little square, the height of the rectangular prism will be X. This dimension at the bottom of the rectangular prism will be 24 minus 2x. And then the width would be 14 minus 2x because you're cutting out x from each corner. So then the volume function for part A would be 24 minus 2x times 14 minus 2x times x. So that would be the answer to part A. For this particular problem, if we wanted the domain for the context of the problem, well, you have to cut out a dimension x that is bigger than 0. And then what is the largest cutout you can be? Well, both of these quantities that I'm underlining have to be positive. So 14 minus 2x has to be positive. So when you solve this, 14 is greater than 2x, which means x is less than 7. Now, why wouldn't you pick the 24 minus 2x? Well, 24 is bigger than 14. You need to start the shorter side. So what this means is you only could have a cutout between 0 and 7, not including 0 and not including 7. So that is a parenthesis for clarity, the domain. Then to find the maximum volume, we're going to go to our calculator and type in the function. So I'm going to go to my calculator and type in 24 minus 2x times 14 minus 2x times x. And in class we discussed, I always start at zoom standard, which is number 6. And I'll see a portion of the graph. On the Casio, I would do the same thing. So I would type in 24 minus 2x, 14 minus 2x times x. And then I would press draw or F6. And zoom standard on your calculator is shift F3 and then F3 again for standard. So I'm going to do that and then hit draw. So both calculators are the same. So when we look at this, we might want to say, well, we need to go higher. So I'm going to go shift window, and I'm going to change the Y max to 100 and hit graph. I notice I didn't go high enough. So then I'm going to go switch to the TI. To get the TI, you're going to go window. And I would have changed it to 100, but now I know that that's not high enough. So I'm going to try 200. And then I'm going to hit graph. And that's still not high enough. So then I'm going to go window, and maybe I'll try 500. And that's high enough. So on the Casio, I'm going to change that. I'll go shift window, and I'll change that to 500. And then I'll draw that, and I can see the maximum. In terms of the domain, if you look at this particular graph, this point here where my cursor is moving over is the 7. So on the Casio, it's really nice. You press G solve and then maximum, and the calculator will come up with the maximum right away. On the TI, it's a little bit different. So you're going to go second calculate. You're going to press maximum. When it says left bound, you're going to go to the left of the maximum and press enter. When it says right bound, you're going to go to the right of the maximum and press enter. And with guess, you're going to move over to the top and hit enter, and it'll tell you the maximum. So the maximum is 2.853, 432.887. We're going to use 3 decimals like calculus. So I'm going to write that ordered pair so I don't forget it. 2.853 and 432.887. So that is the local maximum. So what is the maximum volume? It is the y value of that local max, and that'd be inches cubed. And then for the dimensions of the box, we're going to have to figure out 24 minus 2x and 14 minus 2x. So on the calculator, if I press second quit, the calculator is relatively smart. It remembers the value of x if that's the last thing you did. So I'm going to do 24 minus 2x. And then 14 minus 2x. Oh, I have a typo there because distances cannot be negative. So then I could find the dimensions here are 18.294 inches by 8.294 by the height, which is 2.853 inches.